In this special build edition of the AI Show, we get to hear from Mike Carter, Principal Program Manager on the Azure Cognitive Search team. Mike will talk all about our latest improvements to encryption at rest, VNet integration, firewall with IP restrictions, and compliance to help you build a great search experience without putting your data at risk. Make sure you tune in.
Hi, I'm Mike Carter. I'm a program manager on the Azure Cognitive Search team, and I'm here today to talk to you about what's new in security. We've been doing a lot of work so far this year on security improvements, and I'm excited to talk to you about them. So let's get started. Security is very important. I don't think anybody would argue with that, but to some customers more than others. Financial services, companies, enterprises, governments, they make their service purchasing decisions based on the security features that a service provides. And so we want to meet those demands as well as the demands of even smaller customers, make it actually possible for you to secure your applications and your customers' data without having to jump through a lot of hoops and make it very difficult. So I'll be giving you a demo of how that works and some of the things that we can do, talk to you about some of the easier options, and then maybe some of the little more advanced options. So I'm going to break this topic or section up into three main groups and talk about three different types of security. So there's going to be the security of your data at rest, and that would be you upload the data to us. How well do we store it? How do we store that for you securely? Then there's the inbound security. So this is how do we protect the service endpoint, like the APIs that you use to work with the data in your service. And that is inbound security. And then there's outbound security. That is the security of the calls that we're making to other services. For example, we have a component called indexers that will pull data from your data source. How do we pull that data from a data source without forcing you to open it up to the internet and sacrificing the security of your data sitting in that data source? So let's move on and start talking about security at rest. For a long time, we've actually supported encryption at the storage layer by default. It's enabled today for every single customer service that's in the service using a Microsoft managed key. And it's just something that we take advantage of at our infrastructure layer. We didn't even have to do that much work to actually support it. Now we've added, and this is currently generally available, we've added the ability to encrypt components of the service individually using a key that you provide and then store securely in Key Vault. And so you could have each individual index can have its own key, each synonym map, and coming soon, each skill set can be encrypted using a customer managed key that you provide and store in Key Vault. And like I said, you could have multiple keys, but you could also have multiple key vaults. You could have each one of these keys that are listed here could actually go to a different key vault, and it would all just work. So the key vault itself, you can authenticate using an AAD application or a managed identity, whichever you decide to choose. This is great because it actually is two layers of encryption. So we still have the storage layer encryption as well as a layer at the platform, meaning that data as it comes into the service is encrypted before it even reaches the disk, and then the disk actually encrypts it as well. And so we have multiple layers, and it meets this longer-term goal of what we're calling double encryption everywhere. So all caches, all in transit, and then all at rest on disk, having double encryption everywhere, which is a slightly longer-term goal. We're not there yet, but that's a place that we want to be later this year. And so that's encryption at rest, and that's pretty much covers it. That's exactly what we are planning to do. And so this is something that's generally available, and you can use this today. Now let's move on to inbound. The inbound security is kind of a new area for us. We've always had the API key that you can use to secure your data, and that's what you have to provide to us to be able to make calls into the search service. But we want to harden that a bit. We want to make it a little bit more difficult for interlopers to come and get data out of your index when they're not supposed to. So the simpler option will be IP restrictions. This is a common concept across a lot of PaaS services in Azure. We provide a firewall with IP restrictions. You give us a list of IPs or IP ranges, and you can give us multiple, and we will restrict traffic only to the IPs that you provide. And any other traffic is blocked. It's easy to configure, and it's provided at no additional cost. It's the easy option, meaning you don't need any other Azure components. There's no other pieces that you need to provision in your subscription in order to get this to work. It just works. There's concerns that you'll need to be aware of. Any IPs that change in your application architecture would require you to go update the IP, either range or individual IPs in the service, so that you don't lose connectivity and a part of your application doesn't go down. But it's super easy. It's something that just takes a single call to our management API to update, or you can do it through the portal. Now let's talk about the more interesting, let's say, advanced option, and that's using private link. So this is a big effort that we've been kind of going through across all of Azure, where a lot of the PaaS services, the services like us that have some components are multi-tenant, some components are other, like behind the scenes that we use to manage your service. Private link and private endpoints makes it easier to provide a way for a virtual network to integrate with the service without having to make what looks like calls through the internet. And so when you make your search service private, which I'll give a demo of this in just a minute, but when you make your search service private, it blocks all internet traffic, all traffic coming from the public internet, and will only allow traffic coming in via a private link. And the piece that your VNet sees is the private endpoint itself, and it has a private IP, and this is just an example. You can actually have it be whatever private IP that you decide that you want. And then you have some, let's say in this example, you have a virtual network that's blocked, that you've actually decided to block all internet traffic, and you want to use ExpressRoute to allow only your on-premises network, that your company, to have access to a VM, let's say, and host your IIS server for your web application, and then you want that web application to be able to call into Azure Cognitive Search to provide a great search experience. The way you can give it now the same level of protection that your ExpressRoute peering gives, you can also now have with the connection to Azure Cognitive Search. The endpoint itself for Azure Cognitive Search here is completely private, and there's no way for you to actually kind of get into that service unless you're using private endpoint. One interesting concept here, though, is that this IP, the private IP, can be very stable. You are using a private DNS in this architecture, and you are able to then control when that IP address needs to change. And even if you had multiple private endpoints that you needed to kind of point to, you can create a new private endpoint, let's say for a new Azure Cognitive Search service that you create, and then have it use the same IP, and then downstream consumers here don't know the difference. The consumers of your search service may not even have to be deployed. The updates need to be deployed because they're using the same IP from the private endpoint itself. It's a nice little side effect. It's not something that was like this wasn't set out to do, but it's a nice side effect of the architecture. All right, so let's do a demo. I'd like to talk about how to protect your Azure Cognitive Search service with a private endpoint. Let me switch over real quick and show you the application that I'm working on. This is actually one of our Azure samples that we can provide. I'll have a link to it in the deck when you, if you're able to download it. All this is it's a job portal. You may have already seen it, and I can just give you a little kind of show this stuff. And I do a business analyst. It'll show the autocomplete. You click on the name, it does the search. Here we have the different jobs, and that's great. But so far, as I've been working on this, I've just been using test data. I haven't been too concerned about it. My security wasn't all that concerning, and I was completely fine with just using test data. But I'm getting closer to production. I really want this to use the real world data that I know that we're going to want to kind of have people testing. I want to show my bosses how well this application is working, and so I want to use real data. But I know that my security department is going to be really mad at me if I try to put the real world data in a service that is not protected, right? They would find out, I would get flagged, and I might even get fired, and I don't want that. So let's look at the search service itself. This is right now, this is just a normal Azure Cognitive Search service. I can show you that I have 2 indexes. NYC Jobs has the job data. That's what's particularly sensitive, let's say. And then there's the zip codes. Zip codes are interesting because let's say that these are just the zip code and city and state mappings. It's pretty much public data. So a good example of something where you may not even have that much of a concern about the data is something like zip codes, where it's publicly accessible. Nobody would consider that to be private information. But this data in NYC Jobs, I want to make sure that that's pretty well locked down. And so what I'm going to do is make my search service private. And we have a new tab here called networking. And when I switch over to that tab, you have the ability to turn your endpoint connectivity to private. And so right before I do that, I want to point out the firewall. Like I mentioned earlier, you can have an IP address range using CIDR format or just an individual IP address that you just configure right here in the portal. You set the value, you click save, and you're done. You can even add your own client IP address here. So it's super quick and easy, happens right away, and it's not something that requires an advanced degree in networking. And so that's a great, easy way to do it. But in this case, I know my security team has said that IP restrictions are not enough. If you're going to put any of our data into an Azure service, it has to be protected by a VNet, and it has to be something that has no public internet access available. And so let's do that. Let's click make it private. It's make sure that we know what's going to happen. This will block all consumers of this service. So for example, if you already have the whole team's working on this, make sure that they know that this is happening before you do this, because they will need to be going through the VNet with a private endpoint to actually be able to access the data once this happens. So it takes a few seconds. So that's something that actually will now be happening in the back end. And so with the power of editing, I'm going to make it take no time at all. Oh, and now it's done. So you can see the search service endpoint is now private. Let's just show you what will happen if I try to run the application again. It'll be almost exactly what you would expect, is that it won't work, right? So these pieces of the application don't need the index, but you can see down here it's loading, and it'll just stay loading because it's not able to actually access the search service. And eventually, in a few seconds, the process will time out and we'll get an error coming from code. Let's see if that will happen. Let's give it a second because it's trying its hardest, doing it multiple times, and there we go. There we get the exception, and that's what we would expect. And so what we need to do now is to create a private endpoint that will give a VNet access to this. And so I want to give you a quick kind of overview of the other components that are out there in the service before we kind of move forward. So this looks complicated, but if you've been working with compute and VNets up until now, you should see a lot of things that are familiar to you, because we're not introducing a lot of concepts. So all I did is I created a virtual network with pretty much the default settings. No real special pieces were created for that. Then there's the virtual machine itself that was created inside the VNet. Same, I picked my SKU, but you can pick whatever SKU you want. And then you make sure that it's inside the VNet, and then you're pretty much good to go. And there's not too much that you need to do there. You'll see this private DNS zone at the bottom. This is something that I'll talk about in a second, but I just wanted to make sure I addressed it before we moved on. This is critical. Make sure that you actually have a private DNS zone with this individual name, but creating the private link will also add it for you. It has an option to add it for you. So I'm going to move on and not be too concerned about that. So here I'm going to click private endpoint to create my new private endpoint. And I'm going to call it build 2020 private endpoint 5, say. And then I'm going to choose the same region as my search service, which is West Central US. It's down here. Then I'm going to choose the resource that I want to connect to, and it's going to be a search service. It is this search service, and there we go. And this is the part that I was mentioning earlier. You could have it integrate with a private DNS zone. If one doesn't exist, it'll say new, and then it will create the private DNS zone for you. This is the default subnet that was created with the virtual network. All of these settings, as long as you've chosen your virtual network, are all just the defaults, and you don't have to actually worry about setting them specifically for this endpoint. Great, and then we click create, and once again, this will take a few seconds to a minute to actually finish the provisioning. And through the power of editing, once again, we will. So you can see the private endpoint here in the Azure portal as a connection, right? This is the connection that we're allowing inbound from the private endpoint to this search service. And that actually is the piece where we're actually doing the allowing of the call to come in. That's the private link part. And this in particular was auto-approved, and that's because I had permissions to create the private endpoint, but I also had permissions to approve the connection to the search service, and that's why it says approved here and then auto-approved. But now that the service is private, I wanted to call out one other thing, is that if I go back to the overview tab, all the data plane operations, everything down here in the center, were all related to data that was actually in your search service. And so the portal is not allowed to get access to that. You can't see the indexes, can't see any of the index data or skill sets or any of the other indexers. And that's because the search service is private and protected. If you want to access the search service, you need to do so via the API coming in from the VNet, and that has access to the search service itself. Portal access, as such, is currently disabled because the search service is private. So now let's go back to the VM that's in this VNet and run the application from there. This is exactly the same code with all of the same settings as when it was running on my local machine. But running it from the VNet now, I can connect to the search service using the private endpoint. We can see all of the same data that we had before. If I run it using this, I can see autocomplete and searches just run. And that's because this VM is in the VNet and it's using the private endpoint instead of the public internet to hit the search service. So that's great. You can access your search service with a private endpoint, but what about the API key? Right? And are we planning to support AED authentication? We still get questions about that. I just real quick wanted to mention some options of how to work with that now. We're still considering it as something for the future, but it's not something that we currently have planned in the near term. So what we would suggest is that you tightly control access to your search service, and you have a virtual network that is the one that calls directly into the search service itself using a private endpoint. Then you have a search API on either an app service environment or something that is where you do your security trimming and any other business logic that you would need to perform, and rotate the key. Store your API key in Key Vault. Rotate that key regularly and tightly control who can have access to it. You could even have that API key stored in a Key Vault in your VNet as well. And that way you have a nice tight control over who can actually access your search service itself. And then your web and mobile application developers could be in another virtual network that only have access maybe to call into the search API. Like that's the only thing that you're exposing to them. And that way you can divide up from your data stewards and back-end developers to your front-end developers and have a separation of concerns when it comes to who's able to access what data. It gets us a step forward, is what we would say. This is the big security control where we might make more nuanced, specific controls long-term as we look. But we're always interested in hearing your feedback. So with that, I'm going to now move on to talk about outbound. So similarly, very similar to inbound, outbound has the firewall with IP protection side, and then also the private endpoint side. So let's start with IP restrictions. This has existed for a while. You could do this exact same protection earlier, but we have two new concepts that we're adding here. One is managed identity, and the other is service tags. So let's say you have a data source that you want to reach out to, and storage is a great example. They support managed identity to where you say it is an Azure Cognitive Search service, this service who is reaching out to you, and then in your storage account, you give access to the search service itself so that it's the service identity that you're using and not an individual user or an API key or something like that. And what storage has is if they have firewall restrictions up, you check there's a box on, for example, the storage portal that says allow trusted services. And then we are now, Azure Cognitive Search is a trusted service of storage. So it allow us through the IP restrictions that you have in order to index data from your data source. That's currently planned for preview coming soon in the next several months. You should have a preview up for managed identity. Service tags are interesting. Service tags give you the ability to IP whitelist parts of the service that you can't necessarily see the IPs of when you try to run like NS lookup, let's say, on the search service endpoint, which is typically what we tell customers to do when they want to allow us to call into their firewall. They'll need the IP address of the search service endpoint, but also the IP address of any other internal services that we use to call the data source. The most common scenario where this would be a problem today is if you're just indexing without any skill sets, without any cognitive enrichments, you'd be fine. The calls come from the same search nodes that are the IP addresses that you could see. So that's what the downstream data source would see. It would see the IP address that you would be able to inspect on NS lookup. Now, the cognitive enrichments, though, they run from other machines, other shared hardware that has IP addresses that you cannot inspect. And so in that case, the way to solve that problem is by providing a service tag, and a service tag behind it has the IP addresses and ranges of all those IPs that are internal to the service that you can actually inspect. And so when you want to unblock us from accessing some data source that is protected by a firewall, just give it the IP address that you can see, the NS lookup, as well as the service tag, and then that will allow us then to call into your data source, and making that easy to do. And this is something that's available. And moving on, now let's talk about the advanced option for reaching out to other services by Azure Cognitive Search. And I say other services because this goes beyond data sources. Right now, our current plan is to support private endpoints for data sources and a private endpoint for your customer managed key. So you could have two different private endpoints. It's a private endpoint being a new component of the Azure Cognitive Search service that you define and create as to reach out to whatever other service you need to connect to privately. So it may be a storage account, maybe SQL, maybe Cosmos DB, any service that supports private link. Let's say that that's the place that we need to start, including Azure Key Vault. And that way, you can, similarly to the inbound call, you can have your virtual network, our virtual network connect to your virtual network privately using private endpoint so that your data or your key vault does not have to be exposed to the internet. And it's the same level of protection. So in this case, it's our virtual network has a private endpoint in it with a private link that approves that connection. The interesting part, by the way, is that so we create the endpoint in our subscription. Then there's an approve or deny request it's a private link request that goes to the service owner of, say, Azure Key Vault, storage, SQL, whoever is your admin will see that request and can then approve and deny it. And that's one nice thing about this is that you could have an admin who owns search who adds the private endpoint, and then you could have another admin who is the data steward, let's say, for your storage account, who then will be able to approve it independently. It's not something that just happens, right? It's something that you have governance over and you can have tight control so that it's not just something that's auto-approved if you don't have the permissions to. But it can be auto-approved if you are a person who has the rights to both the Azure Search service as well as the data source or underlying other Azure resource itself. And that way it makes it a little bit more convenient so you don't have to go bounce around and click connection. So this is great. This gives us advanced security for both inbound calls to the search service endpoint using a private endpoint with private link, as well as outbound to your data sources and Azure Key Vault. We could use a private endpoint and private link to reach those without you having to sacrifice the security. A quick word on availability. This has limited availability starting in May. Please reach out to us. There's an email address at the end of the deck. Please reach out to us with any questions, or if you're interested, we're going to be onboarding customers on a limited basis. You'll be able to use, obviously, the IP firewall restriction features today. They're pretty much available right now with preview for managed identity, service tags available today, and the outbound private endpoints are available now. We're just controlling who can onboard to them on a limited basis, but please do reach out to us and let us know. So with that, I'm going to move on to talk a little bit about compliance, just give you a quick compliance update. We've been doing a lot of work recently on a lot of these security features, and they help us get more and more compliant and more secure. We have 59 compliance certifications in the public cloud, 28 in the government cloud. I'm not going to read through all of these. I think the main point, though, is that as we become more compliant, we make us easier for a lot of customers to use, particularly if they have specific needs of security and other compliance needs that we need to meet in order for them to be able to use us, I should say. The reason it's 59 certifications in the public cloud is because of regional certifications. You'll have a specific government in some region that will need a particular compliance, and so that's why that number is pretty high. It's actually a lot of regional certifications that we have, and 28 is for the different government certifications that we have. I'd point you to aka.ms/Azure Compliance for more information. I definitely want you to take a look at our official compliance documentation, and it'll give you all the information that you need about what compliance certifications that we have and what you're looking for there. And once again, like I said before, please do reach out to us. We're always curious what compliance certification is interesting to you. What is the one that you're looking for that would unblock you from using? Please do let us know, and I'll give you the email address for that a little bit later. Want to summarize what we talked about today. So I talked about securing your data at rest. Customer managed keys, double encryption, making sure that your data is stored securely in the cloud. I also talked about protecting your data from callers that should not be able to reach the service using a firewall with IP whitelisting, private link, inbound, and protecting your API keys by storing them in Key Vault. Then I also talked about how you can index your content without having to sacrifice the security of your data sources. I talked about managed identity, service tags, and private link outbound. And then I gave you an update on our compliance story. So I want to kind of reiterate the scope of the work that we've been doing in security and just trying to make sure you're kind of aware of all of the various things that are available to you today. Reach out to us at azuresearch_contact@microsoft.com and give us your feedback. We're always interested in hearing from you. And especially if you have more strict security requirements at your company that would prevent you from being able to use Azure Cognitive Search, please do let us know. With that, we've reached the end. So I thank you very much for your time and enjoy the rest of Build. Thank you.